Students, let us solve this problem of Irodov question number 1.67. A bar of mass m is pulled by means of a thread up an inclined plane forming an angle alpha with the horizontal. What is the question? This is the figure given in the question. This is an inclined plane having angle of inclination alpha with horizontal. There is a block of mass m which is pulled by a thread in this direction in the first coordinate with angle beta with inclined plane. This angle beta is not from horizontal, this angle beta is from inclined plane. Okay, what is the next part? The coefficient of friction is equal to K. Okay, there is a coefficient of friction. Friction force will act between the block and inclined plane. Find the angle beta. We have to find the angle beta which the thread must form with the inclined plane for the tension to the thread to be minimum. So we have to find the beta such that tension in the thread is minimum. Again we have to find what is it equal to. So we have to calculate both beta and tension, but tension must be minimum. So this is the case given. Now first let me draw the free body diagram of this block. The mg, the component of mg along the inclined plane in downward direction is mg sine alpha, and the component of mg perpendicular to the inclined plane is mg cos alpha. Remember that this alpha is not variable, this beta is variable. Now normal will act perpendicular to the plane in this direction and its value is n1. The tension in thread should be in this direction, and let me, the value of tension is T. Now when this block move up the plane, the friction force will act down the plane. And what is the friction force? K into N1. Now this angle is beta. This angle is beta. So let me break the component of this tension T. So the component of tension T in this direction is T cos beta, and component of tension T in this direction is T sine beta. So after breaking the component, there is no use of this arrow. So now from this diagram, first I have to calculate value of n1. So n1 must be equal to mg cos alpha, mg cos alpha minus t sine beta. Okay, now let me that this acceleration is this. So the equation of acceleration is t cos beta minus mg sin alpha minus k n1. n1 is this. So k mg cos alpha minus t sin beta. Force should be equal to mass into acceleration. So collect the t part. So t part is t into cos beta, plus this part is positive plus k sin beta. Okay, this minus part, let me throw it in right direction. So it should be equal to ma plus mg sin alpha, and this part plus k mg cos alpha. Now remember that on the right hand side, all these things are constant. We cannot change this part. For minimum tension, we have to calculate the minimum tension. So when tension is minimum, there is a fixed tension and there is a fixed beta. So there is a fixed acceleration. So this complete part is constant. So for minimum tension, this part should be maximum. So let me write this trigonometric form in a single sinusoidal form. So it should be equal to T into under root 1 plus k square into sine beta plus phi, and should be equal to this number. So m should be common, a plus g sine alpha plus k g cos alpha, and tan phi must be equal to b by a. This is b means the coefficient of cos. Coefficient of cos is 1. So 1 by k. So for minimum tension, this part should be maximum. So value of sine beta plus phi is 1 and this angle is 90 degree. It means that phi should be beta plus phi should be equal to 90 degree. It means that tan beta should be equal to cot phi should be equal to 1 by tan phi. So it should be equal to k. So when tan beta equal to coefficient of friction k, the tension in the thread is minimum. So this is the first answer. Now, what is the minimum tension? So the minimum tension is, this part is 1. So T into under root 1 plus k square should be equal to m into a plus g sine alpha plus kg cos alpha. So the minimum tension T should be equal to m into a plus g sine alpha plus kg cos alpha divided by under root 1 plus k square. Now, in the question, a is not given. This part is not given, and when I read this question repetitively, it is not clear that block is moving or not. A bar of mass m is pulled by means of a thread up an inclined plane, forming an angle alpha with the horizontal. Okay. The coefficient of friction is equal to k. Okay. Find the angle beta which the thread must form with the inclined plane for the tension of the thread to be minimum. What is it equal to? So unless until this A is known, we cannot find the tension. So we can say that for minimum tension means the value of A is minimum. One can write in a very loose sense that the minimum tension is when A is 0 and it should be equal to the remaining part. But I don't agree with this. Unless until A is fixed, we cannot find the value of minimum tension.